In this video, we are going to introduce some basic regular expressions which can make a search within Litera more flexible. Regular expressions are characters that allow the user to search for multiple items in a single query. The CLUVI corpus offers a variety of regular expressions to search Litera. All the regular expressions are explained on the help page. However, in this video, we are going to look at a small handful of some of the most common regular expressions throughout a series of practical exercises. Exercise 1. A backward slash and B create a word boundary. Therefore, words like display do not appear in the results because we have placed a boundary there. However, words like played or playing will still appear in the results because we haven't set a boundary at the end of the word. We could also put a space before the word instead of a boundary, but that won't count any words at the beginning of a translation unit or a quote. Therefore, a boundary is placed to include all instances, regardless of what precedes it. Exercise 2. In this case, brackets return all instances of make sure and made sure. The brackets search for 0 or 1 instance of each character within them. We could add an R to the brackets, but that would not change the results as there are no instances of mere sure in the corpus. So the program ignores that and returns all instances of make sure and made sure. This is a useful regular expression for irregular verbs in the past tense, such as make. Exercise 3. The dash gives a range, in this case from B to D, that is, B, C, and D. Exercise 4. We can form the query as it appears on the screen. With this query, we simply skip the vowels, along with Y and W. This is a useful search to study the pronunciation of the past tense morpheme, as it is the preceding phoneme that determines its phonetic realization. Exercise 5. The vertical pipe translates to OR. Therefore, the query reads as search for all instances of make sure or made sure. This returns the same number of results as the query with brackets from exercise 2, as it is just another way to carry out the same search. Much like in computer programming, where there are often multiple ways to write code to get the same end result, there are often a number of ways to search the corpus using regular expressions that will return the same or very similar results. Exercise 6. The question mark returns 0 or 1 instance of the preceding character. This is why ciego and cegarlo both appear in the search results. Exercise 7. To return all possible forms, we can formulate the query as seen on the screen. Had we placed the unaccented O from niego within the brackets, various forms of negociar would overwhelm the results. Because niego is the only instance requiring an unaccented O, we can separate it with an or statement to eliminate all the extra results pertaining to negociar. However, despite refining the search in such an efficient way, we can see that unexpected words still show up in the results as well, such as negativa and negativas. These are not as easily filtered out, but because they are minimal, they do not hinder our corpus search like the forms of negociar would have. Exercise 8. There are 30 results. We can use the same formula from the previous exercise as seen on the screen, but now we must also search for all forms of shake. To do so, we can use the vertical pipe and formulate the query as follows. It is not necessary to add an E because this way we are also including the gerund shaking. Exercise 9. The backward slash takes a character that normally functions as a regular expression and makes it literal. So here, we are searching for all instances of question marks and brackets. When searching \?, remember that the number of translation units does not equate to the number of questions in the corpus, as there may be more than one question in a translation unit. Finally, notice how with certain letters this does the opposite, such as \B to mark a boundary. With \B, we are taking a letter and applying it as a regular expression. Exercise 10. This regular expression returns any character that can form part of a word. This is why the results in the first query include words like eat, mat, pat, and fat, and in the second query, we can find words like that, goat, and beat. The only thing these words have in common is the number of letters designated by the search query. Therefore, when using \W, character options such as punctuation marks are automatically discarded. Exercise 11. An asterisk means one or more of the previous character, in this case, \W. Here, the search returns any word that ends in AT. However, if we're looking for a word that ends in AT, another way to search for this would be to simply put nothing before A and put a boundary after T, as you can see on the screen. Exercise 12. The simplest way to indicate separate words is to use \W** separated by spaces. Therefore, the search could look like the following. This is very useful when looking for sequences involving multiple words, such as English phrasal verbs. As we can see from the results, searching by particle is a way to locate phrasal verbs in the corpus. This concludes part 3 and the series of video tutorials for the Litera corpus within Cluvy. For further information on the regular expressions that are available, we encourage you to go to the help page, the link to which is located in the header. There you can find all the different regular expressions with examples of how to use each one. We hope you find Litera to be a useful resource for whatever your research objectives may be.